Welcome students, we have a beautiful question on congruent triangles, and since we are continuing our study on congruent triangles, let me just give you this question. So we got the following figure. Okay, so this is A, B, and P, and this is Q, D, and C. We got a 90 degree here, and we got a 90 degree here. Now this is the question. Let me give you this question. So you got this and this. Okay, so the question is as follows. Given A, B, C, D to be a parallelogram, and ABP and QDC are straight lines, angle ADP is equal to angle CBQ is equal to 90. ADP and CBQ, right? So the first part, there are two parts in this question. The first part is prove that triangle ADP is congruent to triangle CBQ. Part 2, explain why AQ is parallel to PC, right? So this is a beautiful question because it has got multiple layers that we need to solve. So foremost, we are expected to prove that ADP. So let me draw the triangle ADP. Now before we go ahead, we've been given A, B, C, D to be a parallelogram. So you can either highlight them with gentle dashes, right? So this is a parallelogram. Right, now my question is, what is the feature of a parallelogram? The feature is the opposite sides are parallel and they are equal. That's an important thing you will have to know. That is, if I were to take these two things, so this is AD and BC are parallel and they would be equal. So this will be the same as this and this will be the same as this. So that is the first observation we have to arrive at. So I can write that statement down. So this is the solution. Since A, B, C, D is a parallelogram, the opposite sides, opposite sides are parallel and equal. So this means AB is equal to DC and AD is equal to BC. So that's the first observation we have to draw. Now, having got that, let me now consider the given triangles. Consider the given triangles. So we have to take ADP. So A here, D here, P here. So let me draw ADP. So let me draw P first, A and P first. So this is A and P, and then D is coming into place now. So this is ADP, this is 90 degrees. I hope you can see that. This is 90 degrees, right? And let me also draw CBQ. We got a C and a B and a Q. So foremost, I have to start with Q and C. So I've got a Q, I got a C, I got a B. And they get connected, right? So this is 90. This is 90. Is there anything else we can get? Are there any other data we can get? So AD is same as BC. AD is same as BC. So clearly you can say AD is same as BC. So we draw the line. We got 90 degree here, we got a 90 degree here. And is there anything else? Now, there's one more information we can arrive at. Now, watch this diagram. A, B, C, D is a parallelogram. So, the opposite angles will be one and the same. So, let me draw that. Opposite angles at A will be the same as opposite angle, or I should say angle at C. So, what do we have here? Right, let me write that down. Solution. I'm starting the solution. This is part 2 of the solution. Since A, B, C, D is a parallelogram, we observe that, we clearly know that, that's the best way to say, we clearly know that angle A should be equal to angle C. Now this is a huge information. You know why? Now what is this? This is angle, side, angle. Also, AD is equal to BC and angle D is equal to angle at B. Thus, by angle side angle A as a criterion, clearly triangle ADP congruent is congruent, or congruent, however you like to spell, is congruent to triangle CBQ. So this is a beautiful, really a beautiful question, which is actually testing our knowledge on congruency. So that's the beauty of this question. This question is basically testing our ability on the subject, on the concept in fact. So having got that, let's move to question number 2. The question number 2, what does it say? Explain why AQ, let me go to the figure, why AQ is parallel to PC. So we have to actually justify why AQ is parallel to PC. Now let's work out the second part. Second part needs some justification. Explain why AQ is parallel to BC. So we need to provide this explanation. Now let us go to the figure. Now we see that AP is actually part of a triangle, right? AP is a part of a triangle, and also QC is a part of a triangle, and they are not part of just triangles, they are part of concurrent triangles. So let me state that we observe that triangle ADP is congruent to triangle CBQ. So ADP, right? ADP is congruent to CBQ. So this side AP and this side CQ, they are part of the congruent triangle, and because of this, AP is equal to CQ. How do I say that? I'm giving you the reason. Because since corresponding sides of congruent triangles are congruent, that would mean are equal. You can use the word equal, right? Because of that fact, corresponding sides of congruent triangles are equal. So I have clearly shown here that AP is equal to CQ. Now the question is, are they parallel? Also, since AP is given to be a straight line, it says that, you can clearly see the question, ABP is a straight line, QDC is a straight line. Also, AP is a straight line. Is a straight line. Now what does it mean? And in the straight line, AB is part of it, and AB is part of it. Since AB is parallel to CD or DC, okay, this would mean, what does this would mean? This would mean this AP will also be parallel to QC, right? AP is parallel to QC. So why do I make it, or I should say, why do I claim this with QC? Since DC is part of QC and QC is a straight line, it's given, and QC is given to be a straight line, given to be a straight line. So that's the rationale I'm using, that's the justification I'm providing. Now this would mean, since AP is equal to QC and AP is parallel to QC, this would mean APCQ should be a parallelogram, right? Because the very fact that the opposite sides are equal and parallel, that is only possible if it is a parallelogram. So this would mean that AQ should be parallel to PC. Why? Since I'm placing there, I know because of space constraint I need to use this. Since APCQ should be a parallelogram, right? So the rationale, let me reiterate the rationale. The rationale for this claim is there are two triangles which are present inside and they are congruent. Now, because they are congruent, their corresponding sides should be congruent, should be equal, right? So that is the first claim. So clearly we have shown that AP and QC are equal. Now we need to show that they are parallel. Now since AB forms part of AP and DC or CD forms a part of QC, and that AB is said to be parallel to DC, this in turn means this is only possible if AP is parallel to QC. Now opposite lines being equal and parallel is only possible if it is a parallelogram. So this means APCQ is a parallelogram, which eventually means AQ should be parallel to PC. So that is the rationale I have used to justify. Of course, I have written a little bit more because for providing understanding. Thank you, students. Enjoy your day.